Hi, this is Mr. Chen. I welcome you to my study room. And if today is your first time of joining me, then I encourage you to subscribe to this channel for more videos. We are still on circle theorems, and today we are going to theorem 6, which is the angle between a chord and a tangent and the angle the chord makes in alternate segment. Let's go straight to details of the lesson. Thank you. This theorem says that the angle between a chord and a tangent at the point of tangency is equal to the angle the chord subtends in the alternate segment. Let's go demonstrate that using the GeoGebra software. And I decide to put the tangent at the top, so we have point C at the top, and then chord DE passes through the point C. Now let's have our chord, our first chord CF, and then we use the chord CF to subtend angle FBC at B, which is in alternate segment to angle ECF. Now let's go ahead and measure angle ECF and C. So angle ECF is equal to 37.8, and then angle CBF is also 37.8, which is a proof of this theorem. This one, because of the relationship between the angles between the chord and the tangent, and then the angle in the alternate segment, I've decided to give a number of examples to help us understand it more. So let's take another circle quickly. As usual, we have our circle AB. We have another point C at a different part of the circumference of the circle, that is under, and then we have our chord DE through, just like the one before, and we have our first chord CF, and then we are going to subtend angle CBF in the other segment, or if you want to call it FBC in the other segment. Alright, angle ECF is 65.7 degrees. Let's now go and measure angle FBC or CBF, whichever way you want to call it, and we can see that that is also 65.7 degrees, which is the proof for this theorem that an angle subtended by a chord and a tangent to the circle is equal to the angle the chord subtends in the opposite segment of the circle. And the segment, we've explained it in the first video for this circle theorem, what a segment of a circle is. So let's take from the opposite segment as well and see, since the tangent is longer, and that's going to give us angle DCB or BCD. I am mentioning DCB because of the way I'm taking it, but then if you want a smaller letter to come, the angle BCD. So angle BCD is 45 degrees, and then let's go and take the one in the alternate segment, which is a major segment, and that is angle BFC or CFB. You can see that it's also 45 degrees, which is a proof of the theorem. But then I would like us to take a very last example, which will have us having the chord subtending different angles in the same segment. And I hope that will remind you of one of the earlier theorems we did. The second theorem, angles subtended by a chord in the same segment are equal. If you forgot about that, you can go back and check that. So we have our circle AB as usual, and the chord CD. The chord must pass through a point for us to see. So let me put a point there quickly. Now let's draw a chord EF, and then we use that chord to subtend an angle in the alternate segment. Let's measure angle CEF. Angle CEF, as you can see, is 45 degrees. Then the same chord subtends an angle at B, which is in the alternate segment. So let's measure angle FBE to see. Angle FBE is 45 degrees. That confirms the theorem. Then, like I said earlier, we want to use the same chord EF to subtend other angles to see whether in the same segment, to see whether they will be the same 45. Just a confirmation of theorem 2, which we did earlier, that all the angles you are going to draw are in the alternate segment, so they will be equal to angle CEF. So we have angle F, we subtend another angle at G. We subtend another angle at G. So angle F, G, E is also the same as angle C, E, F, which is true about the theory. Let's subtend another angle from F to H. You can see that angle FHE is also 45 degrees. So all three are the same, which confirms theorem 2. All those who don't know what I'm saying when I say theorem 2 should go back and check theorem 2. It is there. In case you are still confused, just go back and play it slowly and understand. The introduction to this topic is also important, where I demonstrated a part of a circle that will be needed so that you understand what a segment of a circle is, what a chord is, and when they say we subtend an angle, what it means. Then when you come back and watch this, it will make so much sense. I hope this video has been of help to you. In the next one, we will solve a question using this theorem. Thank you. That is the end of today's lesson. Thank you for watching and see you another time. Bye bye.